2.2a, operations with rational expressions, multiplication and division. Okay, so this is what we're going to focus on today in this lesson. So when multiplying and dividing rational expressions, we follow the same rules as if we were to multiply and divide fractions. So if we had a over b times c over d, what we would do is we would multiply across. So a times c would be ac, b times d would be bd. Okay, and then just remember that nothing in the denominator can equal 0. So in this case, b can't equal 0 and d can't equal 0. Okay, so that's multiplying. Now, dividing fractions, what we do is we keep the first fraction as it is, okay, and then we're going to change the division to multiplication and then take the reciprocal, so flip the second fraction. So if we had e over f divided by g over h, what's going to happen is we're actually going to multiply, and this fraction here, we're going to flip it. So e over f times h over g. And again, we multiply across, and nothing in the denominator can equal 0. Want to make a note of this? If it's ever in the denominator, it can't equal 0. So if it's, the h was in the denominator before we flipped it, and then the g was, so we can't, neither of these can equal 0. Okay, so here we go. Steps for multiplying or dividing rational expressions. So first, factor everything, numerators, denominators, okay? And if you can't factor it, what I do is I put brackets around the expression, and you'll see why. And then if we're dividing, reciprocate the second rational and change the division to multiplication. Okay, that's only if you're dividing. If not, just skip to the third step, state any restrictions, okay? If it was ever in the denominator, it's going to be a restriction. And then multiply the numerators, multiply the denominators, and then simplify by canceling out. Okay, so let's go ahead with example 1. So this is multiplication, so let's just simply multiply across. What's 12 times 114? Well, it's 1368. X cubed times, oh, there's no x's here, so just x cubed. And then there's a y squared in the top. Now what's 3 times 8? I get 24. Then we have an x squared and a y4. Okay, if we were to divide just the numbers, because remember, now we're dividing, okay, we're not going across anymore. Let's divide the numbers, we get 57. X cubed over x squared cancels to an x. And there are more y's in the denominator by 2. So we can say like y squared in the denominator. Now the restrictions on the x or the y, okay, if we take a look at the denominator, x cannot equal 0 and y cannot equal 0. Okay, B. So when we multiply these, we multiply across. Okay, we can cancel out as it is right now because everything is multiplied, or we can simplify first. So if you wanted to simplify first, we would get 6y and then keep the bracket as it is, and then keep the second bracket as it is. Okay, and then that's going to be over 9xy squared. Okay, then we have that monomial in front, and then just keep the x minus 5y bracket as it is. Okay, so these cancel out. 6 divides by 9, and we get 2 over 3. And y cancels on the top, and it cancels one of them on the bottom. So I'm left with x plus 3y over 3x, y. Okay, so taking a look at the denominator here, x cannot equal 0 and y cannot equal 0. But there was a different expression in the denominator with variables. So x minus 5y cannot equal 0, and all we do is rearrange that. So x cannot equal 5y. A little bit different of a restriction, but still a restriction. All right, let's Okay, taking a look at this, again, multiplication, nothing can cancel out as it is, so I'm going to go ahead and factor, okay? So I get 2x plus 3, and then so that's done. And then here, what two numbers multiply to negative 10 add to 3? Well, I get x minus 2 and multiply to negative 10. Yeah, x minus 2, x plus 5. Okay, and then what two numbers multiply to 10 and add to 7? I get 5 and 2, so x plus 2, x plus 5. And then this is difference of squares, x plus 2, x minus 2. So this is really where you want to state your restrictions from. Okay, so if we equate all of these in the denominator to 0, I get negative 2, negative 5. And then I get negative 2 again, so I'll leave that, and then 2. Okay, and now let's cancel out numerator and denominator. So those terms are identical, and now we have 2x plus 3 over x plus 2 squared. So I want to highlight restrictions on rational expressions. When the denominator has a value of 0, the question is impossible to evaluate. Okay, so we can't have any number over 0. It doesn't exist. Okay, so when this occurs, the rational expression is considered to be undefined. Okay, so does not exist, but actually undefined. Therefore, the value that makes the denominator equal 0 is called a restriction. Okay, and that's what we've been focusing on. Now, example 2. Divide and simplify the following rational expressions, then state any restrictions. So, first, I'm going to, because this is division, I'm going to flip the second fraction and write it as multiplication. So I'm just going to rewrite this whole thing. 63a cubed bc squared over 40ab squared. Now that's going to be multiplied by the reciprocal. Negative 15ab cubed c over 27a squared bc4. And at this point, we can multiply. So what's 63 times negative 15? I get negative 945. A cubed and a to the 1, I get a to the 4. B to the 1 and b cubed, again, b to the 4. C squared and c to the 1, I get c cubed. Now, what's 40 times 27? I get 1080. A times a squared, I get a cubed. B squared times b to the 1, I get b cubed. And then I get c4. So let's cancel out. When we divide these two numbers, we get negative 7 over 8. A to the 4 over a to the 3, we're left with an a on the top. B to the 4 over b to the 3, we're left with a b on the top. And c to the 3 over c to the 4, we're left with 1c in the denominator. Okay, so going back to the original and any step down, the letters, like the variables that we had in the denominator were a, b, and c. So a cannot equal 0, b cannot equal 0, and c cannot equal 0. Okay, b. So we can't start yet because there's a division, so let's just rewrite the numerator and the denominator for the first fraction, or the rational expression, and then let's take the reciprocal of the second one. So we get 3x plus 15 on the top, and 9x squared minus 18x on the bottom. Okay, now let's factor. So what can we factor to the first one? Let's factor to negative 3. So, and I'm going to actually switch these in the same step. Negative 3x. Okay, we're left with x plus 2. And I'm going to factor to 4, we're left with x plus 5. Okay, multiplied by, I'm going to factor to 3, x plus 5. And in the denominator, I'm going to factor out a 9x, and we're left with x minus 2. Now we can go ahead and cancel out. Okay, so x plus 5's cancel, and then this x and this x cancel as constants. And now 3 times 3, so we actually have -9 in the numerator. So these two 3's can cancel with the 9. But don't forget the negative. So in the numerator, I'm going to still have -1. And in the denominator, I have 4, bracket x minus 2. Oh, and in the numerator, sorry, x plus 2. Okay, so now restrictions. So again, restrictions has to be anything that ever occurred in the denominator. So I'll highlight these in like a red, okay? So there's a restriction on x plus 5, so x is not going to equal -5. There's a restriction on just the x, which gives us like a restriction of 0. X minus 2, because that's in the denominator as well, which gives us a restriction of 2. But here's the other thing. In the original question, this part was in the denominator as well. So again, if we didn't already list the -5, then we would have to list it now. But -5 is already listed. So those are our restrictions. Okay, last one, C. Again, this is division. So let's go ahead and flip the second fraction, okay? So rewrite a squared minus 4a minus 21 over 2a squared plus a. Okay, I like to personally bracket these. Now we're going to multiply by a cubed minus 9a over, nope, we're going to have to flip it. So 2a squared minus 5a minus 3 in the numerator, all over a cubed minus 9a. Okay, so now let's factor. So in the first one, what two numbers multiply to -21 and add to -4? Okay, I get -7 and 3. Okay, this one's going to be a common factor. I'm going to factor out 2a, and we're left with a plus 1. This is a trinomial here. What two numbers multiply to -6 and add to -5? Okay, factors of 6 are 1, 6, 2, and 3. If they have to add to -5, it's going to be 1 and -6. Okay, but this one's decomposition, so I'll just show you decomposition on the side of the paper, and you may have to do this for these questions. Okay, -5a, I'm going to rewrite that as plus a minus 6a. Okay, bracket the first two, bracket the last two, and just common factor. So I get 2a plus 1, and then I'm going to divide by -3, 2a plus 1. So my factors are 2a plus 1 and a minus 3. And now I'm going to go back over here and sub that in. 2a plus 1, a minus 3. And that's over. Let's common factor out just an a, I guess, here. A. Well, here, this is a little bit different too. So we common factor out an a, and we get a squared minus 9. Then this can keep going as difference of squares. So a plus 3, a minus 3. Okay, so now everything's multiplied. Let's cancel out. A minus 3's can cancel. A plus 3's can cancel. I think that's it. Okay, so what I have left here is a minus 7 and then 2a plus 1 in the numerator. And then we have 2a times a, which is 2a squared. and then a plus 1 in the denominator. So now the restrictions. If it was ever in the denominator, we have to put a restriction on it. So let's go back up here. I'm going to just circle them as I go, okay? So 2a, we have a restriction of 0. A plus 1, we have a restriction of -1. Okay, a, we already did the restriction of 0. We'll get -3 for this one, and then +3 for this one. And remember that we flipped these, so we actually have to put a restriction on the numerator here too, which was originally the denominator. So 3, which I already have, and then for this one, it's going to be -1/2.